Hi everyone, in today's lesson we're going to talk about explicit and recursive formulas for sequences. So we have to first define what a sequence is. A sequence is simply an ordered list of numbers. In general, the form of a sequence is represented by this notation: a sub 1, comma, a sub 2, comma, a sub 3, dot, 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 all the way up to a sub n, where n is the last term. So for an example, I could have a sequence, say I chose 1, 2, 3, 4, 5, and so on and so on. This is a sequence of numbers that has a pattern going up by 1 each time. So I would say this fourth term here is called a sub 4. This first term is called a sub 1, and so on and so on. And the pattern that exists between each term is up 1. Now, we're going to discuss different types of sequences, but for now, we're going to just discuss the definition of an explicit formula. So let's read next. It says, sequences often possess a definite pattern that is used to arrive at the sequence terms. It is often possible to express such patterns as a formula. Such formula is called an explicit formula. So, for example, I want you to write the first 3 terms of each sequence whose nth term is given by the explicit formulas below. So just like a function notation, just like I have, for example, f of x equaling 2x minus 1, I can substitute for x just as I do for f of x into this a of n formula. So if I have a of n, a sub n equals 2n minus 1, I want to find a sub 1. And what that means is I want to find the first term. So everywhere I see an n, I'm going to plug in a 1. So a sub 1 is equal to 2 times 1 minus 1, which reduces to 1. If I want to find a sub 2, everywhere I see an n, I'm going to put a 2. So 2 times 2 is 4, minus 1 is 3. And if I want to find a sub 3, everywhere I see an n, I'll put a 3, and I'll get a 5. So the first 3 terms of this sequence are 1, 3, and 5. Okay? And they do have a pattern. The pattern is technically up by 2. That would be what the pattern would be. I know they're not asking for that, but that's what those 3 terms would be. So the next term is, if I want to find, same concept, find, if this is the explicit formula, I want to find the first 3 terms. So a sub 1 equals 3 to the first, which is 3. A sub 2 is 3 to the second, which is 9. And a sub 3 is 3 to the third, which is 27. So the first 3 terms of this sequence is 3, 9, and 27. Now how am I going from one term to the next here? I'm actually multiplying by 3. Okay? We're going to talk about the names of these different types of sequences later on, but for now it's good to just practice it. So what I'd like you to do now for homework that I'm going to check is to find the 5th term, not all 5 terms, just the 5th term of a sequence that has this explicit formula here. All right, let's move on to the next page. I'd like to now talk about recursion. Recursion is the process of choosing a starting term and repeatedly applying that same process to each term to arrive at the following term. Recursion requires that you know the value of the term immediately before the term you are trying to find. So usually a recursive formula has 2 parts, usually a starting value and then a recursion equation. So let's look. The questions here say find the first 3 terms of the sequence given the formula here. So notice I'm given those 2 parts. I'm given a starting value, a sub 1. So you see how it says find the first 3 terms? I want a sub 1, a sub 2, and a sub 3. So a sub 1 is my first term, a sub 2 is my second, and a sub 3 is my third. I have my first term as negative 4. So I really just need to find the next two terms. And this is where I go to my second part. There's a recursion equation for a sub n as a function of a sub n minus 1 as the term before it. So you may not have a full understanding of what this means just yet, so let's try to understand it. So I have the first term. The next term that I want to find is a sub 2. So given this equation, I want to find a sub 2. So notice how I plugged in 2 for n? I'm going to plug in 2 for this n over here. So I have a sub 2 minus 1 plus 5. And I'm going to start by simplifying this. A sub 2 minus 1, well 2 minus 1 is 1. So a sub 2 is equal to a sub 1 plus 5. So to translate, this says I want to find the second term. I'm going to take the first term, which is this one, and then I'm going to add 5. So if my first term is negative 4, I'm just going to add 5 to it, and that will give me my a sub 2. So a sub 2 is equal to 1. And that will go here for my second term. So now if I want to find my third term, I'm going to rewrite that recursion equation and try to find my third term. So a sub 3, so if I plugged in a 3 here, I'm going to plug a 3 in here. So this becomes a sub 3 minus 1 plus 5. So a sub 3 is equal to a sub 2, if I subtract 3 minus 1, plus 5. Now if you notice, a sub 2 means the second term. So now that I have the second term, which is 1, I can add 1 to 5 and get my third term. So my third term is 6. Now we could apply this process so on, and I could find my fourth term, my fifth term, and so on and so on. So some people ask, if I can understand this terminology, do I have to do this work at all? And the answer really is no. You could just say and translate a sub n equals a sub n minus 1 plus 5. You could write to find any term of a sequence, or of this sequence, to find any term of this sequence which we'll call a sub n, you take the term before it which is a sub n minus 1, and then add 5. Okay, I think that would be appropriate as well. All right, let's try a different type of recursion formula. Same concept, find the first three terms. So I need a sub 1, a sub 2, and a sub 3. Now it looks as though we already have a sub 1. So a sub 1 is 2. So we're going to use this recursion formula. I'm just going to rewrite it twice. So I'll rewrite it here. So that we can find the second and third term. So if I want to find a sub 3, I'm going to plug in n is 3 everywhere I see an n. So I have a sub 3 minus 1 squared plus 1. A sub 3 is equal to a sub 2 squared plus 1. Now remember, a sub 2 is the second term. So what I'm actually doing is I'm squaring the second term and then adding 1. So I think I'm a little too ahead of myself. I probably should have found a sub 2 first, because I don't have a second term. So let's refresh that. We can actually leave what we have here and let's just say, okay, a sub 2 is a sub 2 minus 1 squared plus 1. So a sub 2 is a sub 1 squared plus 1. So what I'm doing is I want to take the first term and then square it and then add 1. So do you see how I couldn't even solve for this out of order? It was kind of good that I did this so that you could see that I can't necessarily find the third term until I have the second term, because I'm going to need the second term. So we can't go out of order, so we have to do a sub 2 first. So the first term is 2, so we're going to take the first term, we're going to square it, and we're going to add 1. So this is 4 plus 1 is 5. That is my a sub 2. And then if I want to find over here a sub 3, I'm going to take the second term, which is 5, square it, and add 1. That becomes 25 plus 1, which gives me 26. So what is an alternative way that you could write this? You could say, to find any term of this sequence, which we'll call a sub n, you must take the term before it, or let's just say you must square the term before it, which we'll call a sub n minus 1, and then add 1. That would be an appropriate explanation. So let's see if it makes sense. We're taking the term, to find the second term, we took this term 2, we squared it, got 4, added 1, and got 5. To get 26, we squared 5, which was 25, added 1, and we got 26. That's it. This is a recursion formula. The reason actually why it doesn't fall into the category as before is because there is no pattern really to get from one term to the next. There's no adding 2, adding 3, multiplying by 6. It's a combination of a few things. It's a combination of squaring and adding. All right, jot down any questions that you might have, and we'll go over this tomorrow in class.